the other hand, boards passing through the automatic insertion process have the components inserted on this, the axial lead auto-insertion unit, a machine station that is capable of bandoliering components to a set program for a selected production run, prior to their automatic insertion into a particular type of board. Therefore, what is happening here is that these boards on the machine are being fed in the correct sequence as the components are cropped from the bandolier. And each component, once in place on the board, is formed and cropped again, this time on the underside of the board. Quality assurance is in fact assured by a form of patrol inspection that examines closely at least 5 boards in every 100 produced by the Universal Axial Lead Auto-Insertion Workstation. Wave soldering of the components that are on the boards at this stage is a simple and an automatic operation, in which each board on this conveyor passes over the automatic fluxing unit, over a heater section that dries the flux before the unit passes over this continually moving wave of molten solder that has a constant temperature of 249 degrees centigrade. In this way, mass soldering of components is achieved, and the boards are then passed through this chemical bath to remove any flux residue, before being progressed to afterflow. Afterflow is the production area where larger units, such as heat sinks, capacitors, and transformers, are soldered onto the boards before they are passed to a section where all flow solder joints are checked and corrected if required. Only after these operations have been carried out does each board pass to final inspection. This is where final inspection of all soldered joints is undertaken in order to assure the integrity of each board. However, in other areas, the concept of quality and the designed-in reliability of each module of each GEM80 system is being put to the test. For example, in this area, the processor complex of the system, all printed circuit boards and power supplies of the system undergo a rigorous 12-cycle thermal shock test procedure that provides a temperature variant from -5 to +70 degrees centigrade at a rate of change of 4 degrees centigrade per minute. In particular, it is this stringent test of quality assurance that will prove the integrity of both soldered joints and the internal through plating of the completed printed circuit boards. In this instance, a GEM80 system is itself controlling a test procedure that is given to every input-output block. Again, this facility delivers a 12-cycle thermal shock test in which the temperature rises from +5 degrees centigrade until, at 1 degree rise of temperature at 1 minute intervals, a temperature of +70 degrees is reached. Following this test, and in the same situation, the blocks are subjected to a dynamic burn-in period of 72 hours at a temperature of 70 degrees centigrade. Because of the high density and the miniaturization within the electronics industry, because of the complexity of processor boards, GEM80 PCB testing is carried out on an automatic basis. The functional testing is done at these 4 test stations and is in fact a sophisticated procedure in which our test programmers, in association with our systems design team, devise a software model of the hardware that we manufacture on this test programming station. It is from this model that the test program will be developed in order that, in logic terms, it will apply a stuck at 1 and a stuck at 0 to every test mode on the board. And further, it will print out the efficiency of the test program itself, in order that we, the company, can offer a guarantee of the integrity and thus the reliability of a GEM80 system. Indeed, it is at this test station area that the now certified printed circuit board receives its own defined serial number, which from this point on allows a history log to be started on a particular board. From this point on, through system testing, through commissioning, and throughout its service life, we, the company, and the customer will have access to that history that will be stored in our computer in quality engineering. It is only then that the system EPROMs that contain the executive software of the GEM80 are added. In time, the total configuration of any particular GEM80 system is put together for the specification of the customer, and the system tester will make sure that the complete system operates to the strict performance figures that are laid down. Only when these performance figures are in total agreement with specification will the complete system be placed in this test area for dynamic burn-in under full operating conditions. The system will remain in this area and in this condition for a period of 7 days at a temperature level of 60 degrees. The design of GEM80 microprocessor control systems has been proved, and in manufacture unusual steps are taken to ensure the quality of each component part of the system. This in turn brings about modules of considerable reliability, which within the configuration of any GEM80 system allows the end user an assurance of quality, together with a backup service that has brought about a high degree of respect and patronage for GEC Industrial Controls Limited in our marketplace, a marketplace which is the world.